Hey guys, this is Mr. H. Hey, I'm going to do a video on completing the square, and I'm going to do this video using visual representation because I think once you see what actually is going on with squares and rectangles, it's easier to understand the completing the square process. So let me start. Um, okay, so here are the goals. In this lesson, I'm going to show you the difference between a square and a rectangle. And I'm going to try to prove to you why a square is generally superior to a rectangle. And if you're given a choice between a square and a rectangle, you should almost always choose a square. The other thing is all quadratics are basically rectangles. And what we're going to try to do when we do the completing the square is we're going to try to take the rectangles and split them up or break them up and make a square or try to make a square if possible. All right. So what I'm going to do is I'm going to do a couple examples of completing a square, and then I'm going to do one problem where I actually use completing the square to solve for x. Okay, so here we go. All right, now, so first thing, which one is better, the square or the rectangle? They both have an area of 36 inches squared. So, but when I say better, what I want to know is which one, can you tell me what the sides are? Well, for the square, it's easy. All you have to do is take the square root of that number, and that tells you that the side is going to be 6 inches, and this side is going to be 6 inches all the way around. Now, if we know that the area of the rectangle is 36 inches squared, we don't know what the sides are. It could be 2 times 18, it could be 4 or 9 times 4, it could be 36 times 1, it could be anything. It could even be 6 times 6. We don't know. So there's a lot of uncertainty about the size. We can't nail it down. But once we know the area of a square, we automatically know what the sides are. Okay, so now I'm going to give one more example. Same thing here. If we know that the area of the rectangle and the square are both 100 square inches, then we can automatically tell what the sides are for this square. It's going to be 10 inches all the way around, right? Because you just take the square of that number. But here we have no idea. Now, even if we were to constrain the sides and say they have to be integers, we still don't have any idea. It could be 1 times 100, it could be 2 times 50, it could be 25 times 4, it could be any of those things. It could be even 10 times 10. We don't know. So it's better to have squares than rectangles, and squares are generally better than rectangles. So I hope that I proved that to you. Now, we're going to use that. Okay, so whenever you have a quadratic, like an x squared plus a linear term, 2x in this example, then that means you have a square with sides x, and it also means you have a rectangle with a side of x and a side of 2, right? And when you multiply those together, you get 2x. So whenever we have a quadratic, then we have a square and we have a rectangle. Now, what we're going to try to do, and I'm going to show you, is we're going to try to make a bigger square because squares are basically better than rectangles. So here we go. Now, in this example, I said the quadratic is x squared plus 10x, right? So it's 1x squared plus 10x. Now, what we're going to do is we're going to try to make a bigger square, and this is how we're going to do it. We're going to split this rectangle, this 10x rectangle, in half. And what we're going to do is we're going to take this half of it and we're going to put it right here on the edge of the square, right? And then we're going to take the other half, if I can get it to, and we're going to move it up here. Now we got to flip it, right? But it's going to be right, it's going to be right here, okay? So now what we have is we almost have a square with one side is going to be x plus 5, and the other side is going to be x plus 5. Now, we almost have a square. We're just missing this little piece right here. Now, if you notice, this side is 5 and this side is 5. So that means that this area has to be 25. So if I add 25 to this quadratic expression, then I have made a perfect square. You see what I've done? When I add this little part here, I basically have made a perfect square that can be written as x plus 5 squared, because that's this side times this side, okay? Okay, so that's what we're doing. That's completing the square. I'm gonna give you another example. All right, so our rectangle is 6x. All right, what we're gonna do is we're gonna split it in half. Now this might not be perfect, but we're gonna move this part right here, and then we're gonna take this part right here. We're gonna flip it, and we're gonna move it right here. Now you can see it's not quite lining up, but it would be right here. Boom. Now, and if you look at it, since we split that 6, this is going to be plus 3. This is going to be plus 3. We know this side is x, this is x. So we almost have a perfect square. We just have to figure out this little piece right here. So if this is 3 and this is 3, that means we have to add 9 in order to make this a perfect square. And we can write this as x plus 3 squared. This side times this side gives us the area of that bigger square. All right, now let's go one more. Now this may be a little hard to understand, but even if one of the sides is negative, right, you can still complete the square. So same thing. We have a side of x and one of the sides is a -8. So what we're going to do is we're going to split that side in half. So it's going to be a -4 here. It's going to be a -4 here. We're going to do the same thing. We're going to take it and we're going to split it in half. And we're going to move that over here. Boom. And then we're going to take, and then we're going to take this one. We're going to flip it on the side. And we're going to move it right. Let me try to get this all lined up. Do that. Boom. Now, we've almost got a square. We just have to figure out what goes here. Now, this side is a -4. This side is a -4. When you multiply those two together, guess what? You're going to get a positive 16. So that's what we have to add here. So even if one of the sides is negative, we're still going to have to add a positive number in order to complete the square. Always. The number is always going to be positive that we're going to add. So we can write this as x minus 4, because this is -4. This is x, this is x. So it's going to be x minus 4 squared. All right, got it? Now, I'm going to use this idea, and I'm going to show you how we solve quadratic equations. All right, so now, here we have x squared plus 10x minus 30 equals 0. Now, we've learned how to do this using the quadratic formula, and basically we have everything on this side, but when we complete the square, we're going to actually move this term, this constant, to the other side. So this is going to cancel. This is just going to be 30. Now, what we're going to do is we're going to focus on this x squared plus 10x, and we're going to see what we need to do to make that into a square. So watch. So just like we did in the first example, since this is 10x, we're going to take half of it, and we're going to move it right here. So that's going to be, this is going to be plus 5. This is x. This is x. Now we're going to take this side right here. We're going to flip it. And we're going to move it like right here. Now, I have changed the side a little bit, so let me fix that. So it's going to go right here, right? And this is also plus 5. So all we're trying to figure out is what do we need to add right here to complete the square? Well, if this is 5 and this is 5, we're going to add 25, right, to complete the square. So if we do this, x squared plus 10x plus 25, right? And we have 30 on this side, but whatever we add to this side, we also have to add to this side. So what we're going to have, let me erase this, is we can rewrite this as x plus 5 squared, and this is going to be 30 plus 25, which is 55. Now, so we know the area of the square. The area is 55. So if the area is 55, that means that the side is going to be the square root of 55, right? Now, it's going to be actually plus or minus the square root, but if we take the square root of this side, we got to take the square root of this side. And so this is going to simplify to x plus 5 equals, and we're almost done. So all we have to do to finish this up is subtract 5 from both sides, and we got plus or minus the square root of 55. Now, that is our answer. Now, if you went and you went A equals 1, B equals 10, C equals a negative 30, and then you did the B squared minus 4AC, and then simplified that, guess what? This is what you're going to get. This is what you're going to get. If you use the quadratic formula, this is what you should get, right? So completing the square will give you the same answer as using the quadratic formula. The only difference is we're using the formula when we do the quadratic square or quadratic formula, but completing the square, we're just taking the rectangle, splitting it in half, and trying to make a bigger square. All right, so let me wrap this up. So whenever you have a quadratic equation or a quadratic expression, you can always make it into a perfect square by taking half of the, splitting the rectangle in half, and then adding those sides to the existing square. And you're always going to have this one little part that you gotta add in order to complete and make it an actual square. So x plus 5 squared is equal to x squared plus 10x plus 25. These two are the same thing. And now once you have that, it's just a matter of solving because we've got a square. All right. I hope this has been helpful. I'm going to post this, and if you have any questions, let me know. All right, so let me stop this.